is, second. Fine. We would like to, so here's our plane. Yeah. Okay, let me see what happens if I just close one of the windows. Sorry about this. Okay. Okay, I think now it should probably work. Perfect. So yeah, we start with a sorry about this. Yeah. So we start with a plane, and we have a point over here, and we want to find the shortest distance from this point to the plane. And the way we do it is we can look at the normal vector of the plane. So we can imagine that the normal vector of the plane is sitting over here. And we can find another vector going from the plane to this point. And then we can project this vector onto the normal vector to get this over here. Any questions about that? To get that component, at least. Any questions about how we would go about doing this? Okay, so we have x plus 2y plus 3z is equal to 12. And we also have 2, 3, 4. Okay, so, and we're looking at the distance from the point to 2, 3, 4. Okay. So now our normal vector is the vector 1, 2, 3. And a vector, so let's find a point on this plane. So we can just take x to be 12. So a point on the plane, we can say 12, 0, 0 is a point on this plane. So that's this point over here. This over here is the point 12, 0, 0. And then this over here is our normal vector that we just found. Okay, now.
Hey, how'd you find the normal vector?
You read it off the coefficients over here. So this is the x, 1. And this is the y, and this is the z. And that's your normal vector for your plane. So in general, when you have a normal vector, a, b, c, then your equation for this plane is going to be ax plus by plus cz is equal to d, some number d. And in order to find d, you just need to know one point on the plane, and you plug that into x, y, and z, and that tells you what d is. That answer your question?
Yeah, it does.
All right, so now we want to find the component of the projection. Okay, I'm going to call this vector, sorry, we need to find this vector. Okay, for this, so now we have this point over here and this point. So let's call this P, and let's call this Q. So this is my Q, and this is my P. So now I want to find the vector between P and Q. So this is going to be 2 minus 12, which is negative 10, 3, so negative 3, and negative 4. Good, so this is my vector PQ. And now I want to project this vector, find the component of the projection of this vector onto the normal vector. So the component of the projection of PQ onto the normal vector, well, that's going to be equal to the dot product, PQ dotted with the normal vector, divided by the norm of the normal vector. Okay, and then this is equal to, so 1 times, so it's negative 10 minus 6 minus 12. Yeah.
Professor?
Yeah.
I think the PQ should be 10 minus 3 minus 4.
10, 10. 2, no, it's 2 minus 12. Oh, sorry,
Or
3 minus 0.
minus
Then,
10,
then,
3, 4.
right, okay, yeah, you're right. One of these were wrong. Thanks. Okay. So now, so then this is going to be negative 10 plus 6 plus 12. All of this over the norm of n, which is the square root of 1 plus 4 plus 9. So then this is going to be equal to 18, so 8 over, and then this over here is 5 square root of 14. Right? Any questions about this? Yeah.
If I use QP instead of PQ, then I would dot product it with minus n, right?
Yeah. Yeah. Or you can just do it. What?
Real quick, for this problem, when you use 1200, did you just make that up, or was there a reason for that?
Yeah, it's just an easy point that I know exists within the equation of the plane. Because again, the plane had the equation x plus 2y plus 3z is equal to 12. So, so you make these 0, and then x is just going to be 12. Yeah. Any other questions? Yeah. Okay. So let's go on to the next problem. Find the equation of the sphere centered at this that intersects the plane at a single point. So in order to do this, so any ideas? Does anyone have any ideas how to do this? So we can look at our plane, and we know where the center of our sphere is. The center of our sphere is some point, and actually, yeah, it's going to be the same point, 2, 3, 4, right? Now I know the shortest distance from here to here, to the plane. So that's just going to be my radius. So I can find a sphere with that radius. So what is the radius over here? It's going to be 8 over the square root of 4, 14. And that's going to be my radius, the radius of my sphere. Because now my sphere is going to go right here, hit it. Not perfect drawing, but it's only going to hit it at one point. Right? Do we agree about this? Yeah.
Yeah.
So now we can look at x minus 2 squared plus y minus 3 squared plus z minus 4 squared. And we can set this equal to 8 over the square root of 14 squared. And this is the equation of my sphere that intersects this plane at only one point. Any questions about this?
Do we have to change it into the form of like x squared minus 2x minus 4x minus?
No. This actually is the correct form. The other way, if you were in the other form, then you would have to like what's it called? Complete the square or stuff like that in order to get it into this form. Yeah. Okay. Next problem. So consider the vector A and B. Find the angle between the vectors. Find the vector of length 8 that is perpendicular to both A and B. Find the angle between the vectors A and negative 3.6a. So let's do it. So the vector A is equal to 5, 2, 1. And the vector B is equal to 2, 1, 2, 2, 1, 2. So the angle between them is equal to cosine inverse of A dotted with B over the magnitude of A times the magnitude of B, which is equal to cosine inverse of 10 plus 2 plus 2 over the magnitude of A, which is the square root 5 squared plus 2 squared plus 1 squared, times the magnitude of B, which is 2 square root of 2 squared plus 1 squared plus 2 squared. Okay. And then this is going to be cosine inverse of 14 over 25 plus 4 is 29, square root of 30. And then 4 plus 4 is 8, 9, 3, 3. Yep. Any questions about this?
On the exam, do you want us to keep it in this form, or like you don't want us to like use our calculators and solve it fully, right?
Yeah, if you can't use, I don't think you can use your calculator, so this would be a perfectly okay way of leaving it. If you can, yeah, if you can't use your calculator, sure. Fine. Any other questions? So now we want to find a vector C that it's perpendicular to both A and B and has magnitude 8. So does anyone have any suggestions of what we can do?
If we want one that's perpendicular, we take the cross product of A and B.
Right. Correct. And then what would you do?
I think then it's like something with like a unit vector and then times 8.
Perfect. Yeah, exactly. Okay. So let's do that. So the vector C, let's say that that's equal to I, J, K, 5, 2, 1, 2, 1, 2. So this is going to be our vector C, and it's going to be equal to I times, sorry, 1 second, 4 minus 1, so 3, minus J times 10 minus 2, which is 8, plus K times 5 minus 4, which is 1. So this is the vector 3, negative 8, and 1. Let's just make sure that it's orthogonal to our two vectors. So I'm going to take the dot product. So A dotted with C is going to be 5 times 3, which is 15, plus, so minus 16. 1 second, I would make, okay, fine. 1 second, 2, yeah, minus 16, okay, plus 1, which is equal to 0, right? So yeah, this is orthogonal to A, and I'm assuming it's orthogonal to B too. So now we can find its unit vector. So E of C, the unit vector, honestly, I think a better notation is like U hat or something, whatever. Anyway, of C is going to be the square root of I'm not gonna, okay, 3 squared plus 8 squared plus 1 squared. Okay, and this is gonna be the square root of 9 plus 64 plus 1, which is going to be equal to the square root of, okay, 10, 74. Okay, so now, so this is the magnitude. Oh, sorry. This is the magnitude of C. Now for the unit vector, so the unit vector that's going to be equal to 3 over the square root of 74, negative 8 over the square root of 74, and 1 over the square root of 74. Now, if we want a vector going in, okay, if we want this to be of length 8, so we just multiply it by 8. So 8 of u c hat, that's going to be equal to 24 over the square root of 74, negative 64 over the square root of 74, and 8 over the square root of 74. Any questions about this? Okay. So next problem is they asked us to find the vector between a and negative 36a. And it's just going to go, so if this is the vector a, so this is the vector negative 3.6a. So the angle between them is pi. And I made a mistake about this. Last time I said that the angle between them was 0, but it is really pi. Any questions about this?
Can you go back to the whiteboard for a sec?
Sorry.
Yeah.
For this question, do we need to show like the proof, like the calculation, or this is sufficient?
This is fine.
Okay, thank you.
No. Anyone else? Okay.
If that
Yep.
was if it's a positive 3.6, is the angle between them 0?
Yeah.
Okay.
One second.
I just have a general question. Are the answer keys to these posted anywhere? So when we go and use them, we could just check our stuff.
No, there aren't any answer keys. I'm gonna try to post these videos onto YouTube. But if you have any questions about like the results that you're getting, you can always email me a page and I'll take a look at it. And I'm gonna try to post these on YouTube later today. Okay, so now the next question is, consider the sphere given by this equation. Find the center and radius of the sphere. Find the furthest distance between a point on the sphere and, oh, so they want the furthest distance between the point on the sphere and the point 9, 2, 3. So we did a similar problem to this a couple days ago. So first, the equation of the sphere, x squared plus 2x plus a y squared plus 6y plus z squared is equal to 15. So first, in order to find the equation of the sphere, what would we want to do?
We need to like complete the square.
Yep. So we're gonna have over here x squared plus 2x plus 1 plus y squared plus 6y plus 3 like, yeah, 3, I guess. 6. Let me see, sorry. 9. 9 should probably work. Plus z squared is equal to 1. Okay, so this would be 25. Okay, so then this over here is going to be x plus 1 squared, right? And then when we open it up, x squared, x times 1 is x, 1 times x is, okay, that gives us that. Okay, perfect. Plus, and then over here, it would be 6. So it'd be y plus 3 squared. So y squared is that, y times 2 is 3, this times that is the other part of that, and okay, perfect. Plus z squared is equal to 25. So the radius is equal to 5, and the center, let's call it P0, is the point -1, -3, and 0. Any questions so far about this?
Why did you change the 15 to 25?
Because I added a 9 here, and I added a 1 here. So I just added the same to the other side.
Okay, thank you.
Pleasure. Okay, so now we want to find the point on the sphere furthest from the point 9, 2, 3. So let's look at the other point. It's going to call it Q. 9, 2, 3. So again, like we did last time, if this is the point Q, and this is the point P naught, and here's your sphere, and we want to find the furthest point this time. So we want to find this point over here. Well, we can find the distance from this point to this point, and then add the radius of the sphere, which we know is 5. And then we will find this point, not the point, we would find the distance, right? So far, is that okay? If you were asked to find the actual point on the sphere that's furthest away, any idea of what you would do? Anyone? So you can look at the vector from here to here. That will at least be pointing in the right direction. So you can take the vector Q, P0. At least that'll be pointing in the right direction. And then you can take its unit vector and then multiply it by the distance that we're about to find. Or if you want to find this point, well, you can again take the unit vector and multiply it by this distance, which is going to be this distance minus 5. Any questions about this?
Yeah, can you repeat that? Sorry.
Yeah. So let's say there are a few different questions you can be asked in this area. One of them is just to find the distance from, let's say, the point Q to let's say the furthest distance from Q to a point on this sphere, which would end up being this point over here. And the question is, how can you find that? And the answer to that is, okay, you can find the distance from Q to P naught. So you can find this distance, and then you can add 5 to that in order to find the entire distance. So then the second question that I asked you is, how can I find this, forget about the distance, how can I find this exact point? What is this point? And the answer is, I can start by taking a vector that goes from P to P0. I'll do all of these. Okay, let's just do all of it, and maybe that'll be clear. So let's first start by finding the distance from Q to this point over here. So first we need to start by finding the distance from Q to P0. So that's going to be, so first we want to find the vector P0 Q. So that's going to be no. One second. Sorry, 1 second. Okay, this is going to be 9 minus 1, which is 10, 2 minus minus 3, which is 5, and 3. So that's the vector that starts from P0 and goes to Q. Now we want to find the distance, so we can look at the magnitude of this vector. That's going to be equal to square root of 100 plus 25 plus 9, which is going to be, so this over here is 24, so 124. So that is going to be the distance from this point to this point, 24. Now, if you want to find the distance from this point to this point, well, all we have to do is add 5, because that's the radius of our sphere. So the answer is going to their question is going to be square root of 124 plus 5.
Wouldn't it be 134?
That's what I was gonna say too.
Probably, maybe, sure. Yep, makes sense. Okay, now for the next thing. So what if they ask you to find the exact point, on the sphere, this point? Well, so we already have this vector. Let's find its unit vector. So here's our vector, and the unit vector is just this divided by that. So u hat of P0Q, that's going to be equal to 10 over 134, 25 over 134, and 3 over 134. So this is the unit vector. And now we know the distance. We know the distance from this point to this point, and we have a little unit vector here right now. So we just need to multiply by the distance, and we'll be hitting our sphere. So what?
I have a quick question. So isn't the unit vector going the other way since it starts at P? Because like earlier you said like it's on
Yeah,
Q.
sorry. Yeah, P to Q. Oh yeah, so all of this is going the other way, but I would put a negative in front of everything, and that will fix it. Perfect. Okay.
But then that would be Q to P though, right? Like
Yeah.
after the negative. Okay.
Yeah. Okay. It's just gonna confuse things. But whatever. Let's leave it like this because that's how it's been going. Okay, anyway, so we have this, and then we multiply it by the other thing. So the vector that we want, let's call it C, is going to be negative 10 over 1 square root of 134 times the square root of 134 plus 5, comma, 5 times the square root of 134 plus 5 over the square root of 134, and then 3 times the square root of 134 plus 5 over the square root of 134. Yeah, is this understood?
Why did you change everything to negative again?
Yeah, I was just pointed out that going from P, this vector goes from P to Q. But I'm looking from the vector. I'm looking for the vector from Q to P, 0. So I can then get the vector from here to here. Because the other vector would have gone actually from, if I put it here, it would have gone to there. I was just looking at the vector that goes from there to there. So I can find this point, because now I can actually figure out what this point is. Yeah, it's this point. Well, you take this vector and you place it at Q and you get this point. My guess is they're not going to actually ask you a question like this. It's a little complicated, but the other one has been asked, so you should definitely know how to find the shortest and the longest distance from a point to the sphere, to a sphere. Any questions about this?
So to find the point, after we know C, the vector, we should subtract it with vector Q, right? To find the point. Because C is the vector from Q to that point. So
Right.
to find the point.
So if you want to find the actual point, you can think of Q as a vector. So you add them actually. So you go from the origin and you add Q plus C and you get this point.
Okay, gotcha. Yeah,
Okay.
thank you.
Yep. Any other questions?
Will the exam be just like a Canvas quiz, just like the practice exams that we just are doing right now?
Yeah.
And is it going to be like 6 questions, or will it be more?
Well, it's going to be 5 questions, I believe, but well, 6 questions, but one of the questions is like, oh, don't cheat or whatever. So not really a question.
So the ones that are posted right now, they're just practice, right?
Yeah. All of those are just practice, and it won't be counted as your grade. The fact that it's in a section that already doesn't count the grade apparently, so I don't actually have to change that, but it won't be counted for the grade for the
So
final.
since it's timed, can we access it after it's timed, after it finishes?
Yeah, I think I made it like unlimited time and like the times they can act. I'm not sure. If you can't access it again, just email me and I'll solve that problem.
Okay.
Okay, any other questions?
Is it open note or no?
No.
Okay, thanks.
Okay.
Hey, Professor. The test, I was seeing in the syllabus that it had like specific, like 3 time slots. Or how are we supposed to access the test tomorrow?
Well, the test won't be tomorrow. Oh, 1 second, sorry. 1 second. Oh, yeah. So the test, it's just gonna appear and you'll be able to take one of the slots. So you choose which one you want to take and you take that, and that's basically it.
And do we have to enter like a Zoom meeting or something?
No, I don't believe so. Again, I'm not making this. This is Joe. I thought he was supposed to be in contact with you or something, but
do you know what those time slots are actually?
do I know what those? I do not.
It says it on the syllabus what they are.
It says on the syllabus. Oh, well, I don't know. Where would it say that? I can access it right now, but let me stop sharing the screen for a second so I don't show anyone anything that you shouldn't see. 1 second.
This exam isn't proctored.
So again, like I am not responsible for making the exam, and I do not. I thought that Joe was supposed to contact you guys and tell you exactly what's going on. So let me see. Let me look up what he's done for now. So yeah, there gonna be a couple. So for now, there are 3 different exams up, 3 different times, and let me look at them. 1 second. So the first one. It says September 23rd at 10 a.m. Till 11:30. I'm not sure if that is actually the correct time or if you just put it there. Let me see. Okay. Yeah, I do believe that you're gonna have to log on to Zoom, and they're gonna send you a place to go to. So I do think that will be the case.
If you go to the Math 231 website, like if you look up Math 231 PSU, there's a whole file on like exam 1 information.
Oh, okay.
Do.
Okay, 1 second.
So like just type in Math 231 PSU and it's the first link.
Okay.
And then click Fall 2020 Exam 1 information.
So no, sorry, when I did this, I get faculty department, Math 31 Lion tutors, Math 31 calculus, maybe it's this, 1 second. Okay. Okay, can you email me this link actually? Because I don't seem to be able to.
Yeah, sure, right now.
Oh, I can find exam information. But yeah, if you can email it to me so I know. Okay, yeah, so this looks like it would maybe be for now. It has time limit of 45 minutes, the exam. There'll be 3 separate windows on Wednesday, September 23rd. Okay, slot A from 10 to 11:30. Slot B is from 6 p.m. to 7:30 p.m. and slot C is from 8 to 9:30. Warning, at the end of these windows, you will be locked out of the time canvas quiz. Well, let's call it a quiz. So in order to get the full 45 minutes, you have to start at least 45 minutes before a closing time. Okay, fine. Actually, let me just share this 1 second. Okay. So after that, you have 10 minutes to upload your answers, single PDF, okay? You're expected to work entirely at your own. Yeah, don't use tutors and stuff. Okay, that's basically it. So did they not mention anything about Zoom? So
Yeah, we didn't get any information about this from John.
yeah. So for now, I think you can assume that you won't unless they tell you that you will need to go to some Zoom page, but yeah.
So will the slots just appear on Canvas tomorrow?
Yes. Yep.
How do we upload it again? Because I like looking at the practice exam, there really is no place to upload it. I'm not sure if there's going to be a different tab.
Yeah, when
said it was like in assignments that you would have to upload it.
Let me see. Yeah, so there's okay. In a separate assignment in assignments tab. Yeah. So there is going to be an assignments tab and you're going to have a place to upload it there. Okay. Any other questions? Yeah, I'm sorry I don't know more about this exam. I thought I would be given more information, and I've been texting or whatever, but so far I've not gotten that much information, but I think it should work overall. 1 second. Okay, I cannot go back to the test. Let me stop sharing the screen for a second again. Okay. Okay,
is there office hours for this class?
There are office hours. I haven't like actually been sitting for an hour just waiting because I don't really feel like that's useful. But if you want, like anytime you want to meet, just email me. You have any questions, you want to talk, set up an appointment. We'll set up an appointment and we'll talk. Okay. Would you feel more comfortable if there were specific office hours?
I don't know. I'm just wondering.
Okay. Fine. So the next question is find values of C so that this line does not intersect this plane. And what we would like to do if we want that, I will have 1 second. It's hard for me to see the whiteboard. Okay. Sorry, 1 second. Yeah, for some reason, when I share the screen, the thing on top is just blocking my view. Okay. 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 So we have two it's just hard. Ah, got it. Oh yeah, perfect. So like I was saying, yeah. So we have a line and a plane. So here's our line. Sorry, here's our plane, let's say, and here's our line. In order to make sure that they don't intersect, if the line is not parallel to the plane, they will intersect. So you can look at the vector v of your line, and you can look at your normal vector at your plane. And you want these to be orthogonal. So you want, so this is n. So you want v dotted with n to be equal to 0. So in the actual problem, they give you the points. So the line is 2 plus 3t, 3 plus 2t, and 5t. 2 plus 3t. So r of t is equal to 2 plus 3t, t plus 2t. No, I don't know. 3 plus 2t. And 5t. And then the plane, 2x plus 3y plus cz is equal to 7. 2x, 3y. So 2x plus 3y plus cz is equal to 7. Okay, so the normal vector, so first the vector v is equal to 3, 2, and 5. And, oh, so yeah, that's v. And the normal vector is going to be equal to 2, 3, and c. Okay, so now we want this to be equal to 0. So we have 6 over here, plus 6, taking the dot product, e dot with n. 6 plus 6 plus 5c is equal to 0, which tells us that 5c is equal to negative 12, which tells us that c is equal to negative 12 over 5. Any questions about that? Okay. So would you guys want me to continue? Like, you can leave if you have something else that you need to do, but would anyone want me to finish the last 3 problems, or would you prefer to just stop here?
Can you finish them?
Yeah. And of course, if anyone wants to leave, they are more than welcome. So the next question is, consider points A, B, C, and D. Find the equation of the plane containing them. Find the parallelogram. Find the vectors of length 7 that is normal to the plane containing A, B, and C. So let's first find the plane containing A, B, and C. So A is 1, 2, 3. Yeah, my computer. 1, 2, 3. See if there's anything else I can close. Hello? Shoot. Hey. Hello? Hello?
I can hear you.
Yeah, what happened? Okay. Okay. So can you hear me?
Yes.
Yep.
So B is equal to 2, 3, 5. And C is equal to 4, 5, 6. Okay. So now if we want to find the plane containing these, we want to find the vector A from A to B. We want to find the vector from A to C. And then we want to find the normal vector of the plane, which would be the vector A, B cross AC. Okay, that would be our normal vector. So let's do that. So the vector AB is the vector 2 minus 1. So 1, 1, 2, 3 minus 2, 5 minus 3, 2. And the vector from A to C is the vector 4 minus 1, which is 3, 5 minus 2, which is 3, and 6 minus 3, which is also 3. Okay. Now, the cross product is going to be, so the normal vector is equal to I, J, K, 3, 3, 3, and 1, 1, 2. Okay, so now this is going to be equal to, okay, I times 3 minus 6 is going to be negative 3 plus j minus j times 3, again minus 6, so plus and 3, right? 3, good. And then plus k. So here's k, and then you're going to have 3 minus 3, so that's 0. So the normal vector will be negative 3 and 3, 0. And it works for this one. It's orthogonal to that. If you take the dot product, you get 0. If you take the dot product with that, you get 0. So good, it works. And then once you find the normal vector, you can set up the equation of your plane. So this is negative 3, 3, and 0. So the equation of the plane will be negative 3x plus 3y is equal to d. And then we can figure out what d is by plugging, let's say, plug a in. So this is going to be 1 and 2. So, sorry. So that's going to be negative 3 times 1 plus 3 times 2. Whatever, 2 times 3 is equal to d, which tells us that d is equal to 3. Which tells us that the equation of our plane is negative 3x plus 3y is equal to 3. Any questions about this? Okay. Second. So the next question that they ask us to do is find the area of the parallelogram with vertices A, B, C, and D. So let's look at how this parallelogram looks. So the real question is D, if we checked, I mean, well, it's going to be a, oh, is it a, did they say, he says parallelogram? Oh, good. So if we're assuming it's a, okay, fine. Here, here's your A and B, C and D. And he's telling you that it's a parallelogram, which means that we can use the equation that we know that AB cross AC, the magnitude of that gives you the parallelogram. Or in other words, if I just look at this normal vector and I take the magnitude of that, so the magnitude of the vector negative 3, 3, 0, let's see if this works. Yeah, cool. Is equal to the square root of 9 plus 9, 18. So that would be the area. What's next? Find the length, the vector of length 7 that is normal to the plane containing this. So this, you just need to take your normal vector divided by 8 and multiply it by 7. So first we divide this by 18, square root of 18. So we're going to have negative 3 over the square root of 18. 3 over the square root of 18.
Where'd you get square root of 18 from?
The magnitude, this This squared is 9, and this squared is 9, and then you add them.
I got you.
And then 0. So this is a unit vector, and then you multiply this by 7. So the answer is negative 21 over the square root of 18, and 21 over the square root of 18, and 0. Any questions?
Professor, so what if the parallelogram is not a parallelogram?
Yeah, then they can ask you that question.
Yeah, what should we do? Because I saw it on homework.
Oh, you saw it. Okay, so if it's not like a actual parallelogram, you can split these, and you can find the area of this triangle. I'm just assuming this is a parallelogram. If it's, yeah, well, anytime you have, it's always going to be a parallelogram, so you can always do this. You can always, you don't have to split this. I'm sorry. You can always look at I mean, what area would you can always look at the magnitude of this. What area did they ask you for? They gave you 4 points, right?
They give
Hello?
They gave you a point and they said it's a quadrilateral. And those points does not make a parallelogram.
Okay, so if it's not a parallelogram, we can imagine a shape like this. Then yeah, you can always split it into 2. And we know how to find the area of this triangle. It's 1/2 of whatever. And we know how to find the area of this triangle. It's 1/2. So you just add them. It's possible that's what he meant, but he's using the word parallelogram. So I'm just going with it. But if it's not a parallelogram, yeah, you can always do this. Does that make sense?
Yeah, thank you.
Okay, and the area of these triangles, if let's say this is A, B, and C, is going to be the magnitude of the vector AB cross AC over 2. Yep. Any questions?
And I mean, those points are arbitrary, right?
Yeah. So this over here will give you this area. And then you can find this area. Similarly, let's say this is D. So the area is going to be, let's call it dB cross DC magnitude over 2. Yeah? And then you add these. Okay. So the next question, they say find the equation of the plane that contains this line and that point. So first, just to it's always good, by the way, to make pictures. So before some problems, especially this type of problem, just make a picture. You have a line and you have a point. So just put a line and a point. And we want to find the plane containing this. Well, the line gives us a vector. We did a problem like this before. And then you create another vector. So this is the vector V coming from the line. And then you create another vector going from the line to the point, and you use the R0 over here. But it doesn't matter. Any line any point on the line would work. And so then let's call this, and let's say this is Q. So this is the vector R0Q. And then the equation of and then the normal vector is going to be V cross R0Q. And you would be able to continue from there. Yeah, does that make sense?
Yep.
Okay, so let's actually do it. Okay. So in our situation, our line is 2 plus 3, 3 plus 2, and 2t. Okay. R of t is equal to 2 plus 3t, 3 plus 2t, and 2t. Okay, that's it. My computer is a little slow. Ah, perfect. And then the point Q is equal to 5, 4, 3, 5, 4, and 3. So now, the vector v is equal to 3, 2, 2. And, okay, R naught is equal to 2, 3, 0, 2, 3, 0. So now the vector from R0 to Q is equal to 5 minus 2 is 3, 4 minus 3 is 1, 3 minus 0 is 3. So this is going to be our vector. So now the normal vector, okay. Now the normal vector is going to be I, J, A. Okay, and then 3, 2, 2, 3, 2, 2, and 3, 1, and 3, 1, 3, 3, 1, 3. Okay. So now we have that this is equal to I times 6 minus 2 is 4 minus j times 9 minus 6 is 3 plus k times 3. 3 minus 6 is negative 3. So my vector is going to be the vector 4, negative 3, and negative 3. Okay, so this is my normal vector. Let's just make sure it works. So let's dot it with v. So that's 3 times 4 is 12. And then negative 3 times 2 is negative 6. Not good. So it works. It's 0. So now we want to find the equation of the plane. So we can take any arbitrary point. Let's just choose R0. So the equation of the plane will be 4x minus 3y minus 3z is equal to d. Okay. Okay, so now we can plug in the point R0, which is 2, 3, 0. So this is 8, and this is minus 9, and this is 0 plus 0 is equal to d. So it's negative 1. So the equation of the plane is 4x minus 3y minus 3z is equal to negative 1.
So you plug in R naught for the equation of the plane?
I did, yeah. You don't have to. Any point on the plane would work.
Okay.
You need the normal vector and you need a point on the plane. And we know that R naught is on the plane. so it works. But okay, and then the last question is, I think, yeah, you guys should be able to do that by yourself at this point. So I'm just gonna stop here. So are there any questions? No? No questions? Okay, so see you all next class. Bye.
Thank you.